Next, let's look at hyperbolic graphs, hyperbolas that is not centered at the origin. So far, we've only seen stuff that's centered at the origin. Now, if it isn't centered at the origin, it looks very similar to the moving plan of the ellipse. That is, you simply take x minus a number h. H can be positive or negative. And y minus by k, same thing. K might be positive or negative. And that will move the entire hyperbola center now to the new point where it's centered at hk instead of originally it was at origin, which is 0, 0. And so once we moved, then we got our equation. Okay, this would be the new equation after the move. So let's do an example of that. The one thing that we must pay careful attention to is the asymptote. That is, the asymptote is going to be also moved as well, and the new equation for the asymptote is going to be like this. It used to be just b over ax. Now we have to move the x and the y the same way we move the center. But we'll look at that in a moment. Okay, so let's turn to the next page or something, and let's try to do the example on page 826, example 3. Now, the page right before 825 does tell us some of the details of how to move a hyperbola to a new point. So when we need to, we'll refer back to all that information. But right now, let's see what we're supposed to do. Example 3 says, find the equation of a hyperbola. What is the standard form of equation of the hyperbola that has vertices at 0, minus 2, and 6, minus 2? All right, so then so the vertices at 2 points that is both minus 2, okay, which is, this is 0, and then this is 6. All right, so the hyperbola goes, and the focuses are at minus 2 and 0, so if the focus is about minus 2 here, and then 8. 8 minus 2. So this is 8 minus 2. And so then the hyperbola then looks something like this. Okay, goes left and right, 6 minus 2. And so that's a normal form of a hyperbola. So we just need to figure out where its center is, and we also need to figure out what the number, what b is. Now, being that its vertices are from 0 to 6, that means the distance a is the narrowest part of the hyperbola. So a equals to 3. That is half of 6. So this part, half of this, a is a, and that should be equal to 3. This is also a. Okay, they're both a's. And so anyway, and then so a equals to 3. We know that much. And so next we need to figure out the focus, and then c is equal to so c is a little bit more than a. That, let's see how much, 6, and c goes all the way to 8. Let's see. Okay, what's this point? This is 3. Okay, so c goes all the way to 8. That means this is 3 and that's 6. C goes all the way to 8. That means c equals to 5. C equals to 5. And it's just a matter of a is 3, right? And the focus point is 2 more, so make c 5. And following this formula right there, that means 5 equals to, so 5 squared equals to 3 squared plus b squared. And that shows us that b has to equal to 4. And so that is all this stuff should give us the equation of the hyperbola that is centered at, and this is the new center. Where is it? It is it goes from 0 to 3, so it's located, the new center is at 3 comma minus 2, because this is all minus 2 in the y coordinate. The question is how far out is it? So the new equation then becomes x minus 3, okay, that's the x coordinate, 3 squared, divided by a, which is 3 squared, and then minus y minus b, which is minus 2 squared, and then divided by b, which is 4 squared. Wait a second, did I say a equals to, well, whatever. So that should be across. Y is, does that matter? Maybe it doesn't matter. Okay, so that should be equal to 1. Now let me check to see if I got this right. X minus 3 over 9, y plus 2 over 16 equals to 1. I got it right. All right. Okay, so I didn't make any small mistakes. And, and so that is example 3. So next. So next, let's look at page 827, example 4. But before we do that, let's look at that the gray box where we have to focus on certain information. What matters here is the equation of the asymptotes, because the asymptotes show us basically the guideline of how wide or narrow the hyperbola is. So look at the gray box in there. Okay, we have say the equation. This is the left and right opening hyperbola where x is in front. In that case, the asymptotes are plus or minus b over ax. Y equal to plus or minus b over ax. Now, if it is the up and down hyperbolas where it opens up or down, and so that the y goes in front. Okay, in that case, then the asymptotes of the equations are y equals to plus or minus a over b. So that is something to bear in mind. Okay, now that we know that, let's draw this thing. Okay, I have it written down here. Y squared over 64 minus x squared over 36 equal to 1. Being that y is the positive one, then we know that this is one of those up and down things. Like it says in the just above the problem, where if y squared is positive over a squared, then you know that this is the vertical ones. And the vertical hyperbola, in other words, the hyperbola looks something like that. Okay, and the question is exactly how much does it open. It is centered at the origin because we don't see any h or k's here, meaning that they are 0. And then so a is equal to, let's see, we will call this a is equal to 64. 64, the root of 64. A squared is, so that means a equals to 8. So the distance here is 8. Which means this thing is 8. Okay, so this point is that's 0, 8, 0, 8, and this is 0 minus 8. So that's where a is. So the hyperbola opens up and down through the vertex a. And then the next thing we need to know is the asymptotes. The asymptote y is equal to, and so b right here, b equals to 6, okay, and the square root of 36. Asymptotes are y equal to a over b, plus or minus. So a over b is 8 over 6, or 4 over 3 x. So 4 over 3 is slightly more than 1, which means the asymptotes are slightly steeper than just y equal to x, but not too bad. Yeah, something like that. So we'll draw the asymptotes, and once we draw that, then we know how to draw the hyperbola. The vertex is here. It approaches the asymptotes on both sides, okay, and like that, and it approaches the asymptote, and that is my hyperbola. And that is how we might graph this thing. Let's see. Did the book graph it? Yep, it has graphed it. It also talks about other points, but I really don't care about the other points, like where the focus is. The focus doesn't really tell us how to graph it. So this is mostly how to graph it, is to the asymptote is what matters in terms of graphing. Then it shows you how wide it opens. Because if the asymptote opens up very wide, you know, if this line, instead of like this, it goes all the way down, then it means your hyperbola is very flat. right? And whereas if the asymptote goes straight up, very close, then you know your asymptote is very narrow. It just shoots straight out. So so that is that. And of course, you can also type this equation into the Desmos calculator or some other calculator, and it'll pop out the graph for you faster than you can blink, which is also very cool. Next, we will consider graphing hyperbolas that's not centered at the origin. Example 5 on page 829. So next, let's look at example 5 on page 829. And that's we need to graph this hyperbola, which is centered at some odd point. But however, we're not given what the point is. The hyperbola is multiplied out into this generic looking thing, and we're supposed to well, turn it back into the standard form so we can tell what A and B are, so that we can plot the thing. Okay, you know it's a hyperbola because there is, look at this, there's a 9x squared minus 4y squared. If this symbol had been a plus, this would have been an ellipse. Okay, we know it's a hyperbola because we have the x squared and y squared as the highest powered variables, and there's a minus sign. That is the critical point. So knowing that, now we're going to do the same trick that we did before with the ellipse. That is, we're going to do that completing the square thing, and then use the exact same trick to reduce this to standard form. So let's do that. So we have we round up the x's together. So we have 9x squared minus 36x. And we are going to take 36 divided by half and then square it. That's the entire trick of completing the square, which is 36 divided by 2, that's 18. So plus 18 squared. Okay, and I'll just write it like this. We'll deal with it later. So and then next we have minus minus 4y squared, and then wait, I said that wrong, because the 9x, we have to factor out the 9. This is not how it done, how to do this. Let me erase it. Yeah, we have to first factor out the 9. I forgot all about that. So to factor out the 9, we get the 9x squared. Okay, 36 factoring out 9 becomes 4, because 4 times 9 is 36. So the 36x becomes 4x in the parentheses, and then it becomes and then that's when we do the divide by 2 and square business. 4 divided by 2 is 2, square is 4. So that's how that works. Okay, and so that's that part. So next we have the y, the same thing. For y then we have the minus 4, factor out the entire minus 4, so the y in here is positive. So minus 4 y squared, and then factoring out minus 4 out of the minus 40, so we have plus 10y left. Plus 10y, and then take the 10 divided by half. Half of 10 is 5, then square it. That gives us positive 25. Okay, and then we'll put the 388 on the other side of the equation, becomes a positive 388. It used to be negative. Okay, and then we are going to, so during completing the square, we have added an extra 4. This is added an extra 4 times 9 is 36. So we need to do the same thing here at 36, because we added that for no good reason. Okay, so we need to add it on this side so that the equation continue to be equal. Otherwise, this side will have 36 extra for no reason. And similarly here, we have an extra minus 4 times 25. That is minus 100. So we'll do the exact same thing here, minus 100. So now both sides are even. And and then so the next thing we need to do is so this becomes 9 times x minus 2 squared, okay, minus 4 times, this is y plus 5, y plus 5 squared. Yeah, if you're in doubt, just multiply this out. It will become exactly that. Similar here. Multiply this out will be exactly that. and that will be equal to, this is 288 plus 36. I don't know what that is. Let's use the calculator. So let's do, I'll just do 388 minus 100 is 288, and then plus 36 is 324. Okay, so that equals to 324. Yeah, okay. And then we need this thing to be 1. So for this to be 1, we are going to divide everything by 324, the whole equation. So each part here will be divided by 324, 324, and 324, and cancel things out. What is that? 36, I think. This cancels out to be 36, okay? And then this cancels out to be something 81. Yeah, this cancels out to be 81, and of course this just becomes 1. And that is our equation. That x minus 2 over 36, y plus 5 over 81, and equals to 1. That is our equation. But what were we supposed to do here again? We are supposed to graph this thing, all right? And now, being the x is the one that's leading, okay, x is the positive one, y is the negative one, we know the hyperbola opens left and right. That is, the hyperbola looks something like this, okay, the left and right hyperbola. And then and in that case, let's see, which one's a? So this number is the a. So the narrowest part of the hyperbola is the square root of 36, which is 6. So a equals to 6. Okay, let's draw this thing. A is 6. A equal to 6, and then b equals to 9. So b is bigger, and let's see. So then let's look at the asymptote in this case is b over a. So the asymptote is quite deep. Not that it matters. So what happens is that we will graph this thing. Okay. Do I have space for it? Maybe over here. All right, I'll graph it over here, maybe, or just here. It doesn't matter. So let's say a equal to 6. I'll call it this thing 6. Here's minus 6. Well, no, that wouldn't be quite right, because we're not actually as centered as 0 right now. We are centered somewhere else. So wherever the center is, actually, we know where the center is. The center is at 2, negative 5. So here's the center, which is HK, okay? And the center is located at 2 and minus 5. And this is this is something that opens that way, okay? So we'll go this way and then go 6 units. 2 plus 6 is 8. So this is 8, minus 5. And then that is where where it hits. And then over here is, let's see, 6. And then over here, okay, this is whatever that is. And then we have, we'll just draw the hyperbola this way. See, the hyperbola go this way. We also should probably do the b over, what is the equation, the asymptote has a slope b over a. So b is 9. So the asymptote is, the slope is 9 over 6. And that is equal to 3 over 2, which is fairly steep, okay? So if the asymptote is fairly steep, like this, so the hyperbola actually goes, well, that is not cute. We need to go through the center. So the hyperbola is actually going something like this, is approaching the asymptote, both top and bottom. So something like that, okay? And that's about how we would do this type of thing. It's a bit tedious to do this type of thing. And but okay, so here's the answer after you've gone through all that. See, being that the asymptotes are around somewhat steep, being that they have a slope of 3/2, which means that you have to draw the hyperbolas wide. They open up much wider like this. But otherwise, there isn't really much to it. This kind of thing. So let's just call this done and move on to the next problem. So next, let's look at example 6 on page 831. We are supposed to find the equation of this hyperbola. Okay, and so there is something that is we're giving some dimensions. It says that the narrowest part of the hyperbola is 60 meters. In other words, the A is equal to this, from A to minus A is 60. So A is equal to 30 right here, okay? And 30 on the other side. And then also, it says that there's one point here, on top, where there's a point where the height is going to be 79.6, where the width is going to be 72 but divided by 2. The whole thing is 72, so half of it is 72 divided by 2, and that would be one point on the hyperbola. I drew it on this side, but what I mean is draw it on this side. In other words, the coordinate of that point is 36, okay, 72 divided by 2, comma 79.6. And then that is one point. That is when x equal to 36, y equal to 79.6. And then we know what A is, and that's about all we know. It gives us the total height of the thing, which tells us nothing. Okay, so that is a worthless piece of information. This is all we need. This tells us what. So the formula for this, the equation for this thing is going to be x squared over 30 squared, okay, and then minus. That's the critical point of hyperbolas, is minus let's see, y squared divided by b squared. We don't know what that is, and that equals to 1. And which means we just need to figure out what b squared is. Now we don't know, but we know that when x is 36, y is equal to that 79.6 thing. So from that information alone, we can figure out what b is. Just plug in x and y into this equation, and then we can calculate b. So to calculate b, we will have b equal to, we'll move b to this side, okay? So we'll move the whole thing over, y squared over b squared, and that will be equal to x squared over 30 squared plus, and then minus 1, right? And then we're going to flip this around, being that b is in the denominator, or should I say, I'll move the b over here, okay? And move this whole thing down here. So the equation reads like this. B squared is on this side, equals y squared divided by this entire chunk of stuff, which is x squared over 30 squared minus 1. And then we're going to take the square root of this thing, and that will give us b. Okay, so let's take the square root of this whole bit, and then that gives us what b is. B equals to that thing's square root, where y is 79.6 and x is 36. So let's do that. Let's see if I can do it this way. Does that block the view? Yeah, it does. So I'll do it on the other side. Okay, so to do that, then I'll write it out a little better, so maybe that make it a little more pleasant. So that equals to square root of y squared is just y, and so b equal to just y is 79.6. Okay, and then the square root of down here, there's nothing we can't do a thing about. So let's write it all out. So 36 squared divided by 30 squared, which is 900. I'll write that out minus 1. So we just need to punch this in, then we're good. Okay, so let's do that. And so let's do, let's see. Okay, got it. Let's see. We have 79.6 divided by square root of, we don't need parentheses because the square root includes all that stuff. So 36 squared, okay, divided by 900, and then minus 1. And that should equal to something, 120 point something. Okay, so B equals 120 point something. But before we do anything, let me check to see if I'm right, because I wouldn't want to do all that and just to get it wrong. Yes, actually they gave B squared, which is okay. So we'll just say that B equals 120, and B squared is whatever it is, and then so the equation is x squared over 30 squared and y squared over 120 squared, 20 squared, and equals to 1, and that should be the answer. And the book says that you should have your answer in accurate to 4 decimal places. Yeah, I don't see why. I mean, what would be the purpose? And I mean, the information that they gave us are nowhere near 4 decimal place. So what's the point of giving the answer in 4 decimal places anyway? Especially when the answer is so big. The answer is 14,000 something, and then you get the 4 decimal place. Yeah, nobody's going to look at it. But anyway, so that is that. So we have come to the end of this section, and let me talk about the homework. So for homework on page 832, please do problems 9, 21, 27, 39, 47, 51, 53, and 55. And I won't be going over the homework because they're so similar to the homework in the ellipsis, and most of the homework isn't long either. Okay, I think there's like one of them that you have to do completing the square, but otherwise the rest should go fairly quickly, that you can get through it. So and that will be the end of this section.